Hi there, my name's Millington-Smith and I'm the Applications Manager at QLM. I'm going to talk to you today about how we are enabling organisations to achieve net zero through mitigation of greenhouse gas emissions. Our focus is on methane, a much more potent greenhouse gas than CO2, but with a shorter lifespan in the atmosphere. Mitigating global emissions of methane can have a quick, measurable impact on climate change, but you can only mitigate what you can measure, and this is where current techniques fall down. Methane leak detection and repair is slow, labour-intensive, and only provides a snapshot in time of a facility. Highly temporally resolved leaks, vents, even super emissions can go missed and unreported. To achieve net zero and beyond, continuous monitoring is required. But so far, no solution yet achieves the industrial requirements of detection, localisation, quantification, and industrial scalability.
Based in Bristol in the UK, QLM was founded by our CTO, Zhao Ai, during his studies at the University of Bristol. Initially backed by the university's quantum technology accelerator, QTech, he is joined at the managerial and strategic levels by renowned experts from the academic, photonic and oil sectors, providing crucial direction towards the market. QLM takes LIDAR, a range-finding point cloud technology that has become smaller and cheaper over the last decade, and combines it with quantum single-photon detection, capturing the tiny backscatter from the LIDAR and processing it spectroscopically. Matching the LIDAR and detector to the absorption wavelength of methane delivers a low-power, eye-safe, highly sensitive tunable diode LIDAR gas sensor, built with off-the-shelf components that will enable price reduction as production scales. Our initial product is a fixed-in-placement methane camera on a versatile pan-tilt system with an intuitive browser-based graphical user interface. It can monitor ambient methane concentrations all the way up to super emissions at a range of up to 200 meters and uses wind speed and information data from an integrated anemometer to accurately calculate an emissions flow rate. This has been tested in controlled release studies, notably at Total's Taddy facility, where solutions are challenged to find methane release at unknown rates and locations on the test site. QLM's prototype performed admirably, regularly detecting, localizing and quantifying methane emissions over a wide dynamic range. In April, QLM was named among the 2021 BNEF Pioneers, companies answering challenging questions in the fight against climate change, in our case, that of continuous environmental monitoring. In May, we successfully closed a seed round of funding, generating £3.1 million from a consortium representing both green technology and oil and gas interests, giving us a runway towards a Series A round in 2 years' time. Over those 2 years, we plan to scale production, driving down the unit cost. The camera will be made smaller and lighter, enabling it to be flown from a UAV. ATEX-compliant cameras will enable deployment inside hazardous areas, the variety of gases we measure will broaden, and the software will be expanded to include full automation of the monitoring procedure and incorporation into site safety systems.
QLM's quantum gas camera is the only solution that enables an accurate measurement of greenhouse gas emissions in an affordable, scalable way. We are currently seeking industrial collaborators for real-world field trials on onshore facilities in 2022, demonstrating the superiority of continuous monitoring.